All right, great. Thank you, Dr. J. Okay, so has everyone got the lab already? Hopefully, yes, because it's on the website, and I got something here. Larissa, you sent out an email, right?
What's that?
With the join.me?
Did I?
Yes. Oh, right. Sorry. Okay, so the lab today is actually, if you understood some of the principles behind hypermesh and finite element analysis, this one will go a lot easier because NX-Nastran I find is a lot more user-friendly than hypermesh. So basically what we're going to do is we're going to take this rod part, which is a tutorial part, and that's on the website, so make sure you download that part file. And we're going to run through, we're going to give it a material, we're going to idealize the geometry, we're going to mesh the part, apply loads and constraints, and then we're going to solve it and look at the results. And this will go pretty quickly. So at the end, you're going to generate a simulation report, and I'll show you how to do that. And there's also another document on that I made this morning, how to create a simulation report. And it's just real easy. You just have to know where to click and what to select to make this. So make sure you get that as well. So once you generate the simulation report, you're going to want to make sure you have pictures in that report and you save it as a PDF. And then you're going to email that PDF to the ME471 email. And then you're also, afterwards, we're not going to do this in lab, but you can do this afterwards. Once you finish the tutorial, you'll do basically the same thing to the lower control arm from lab 4. So this green part here, we're going to do a similar analysis on in your, just by following the tutorial. And then you'll do the same thing. You'll make a report as well. You'll put images in it and save it as a PDF file. Right. So okay. Here's what I'm going to go through it pretty quick because it'll go pretty fast, and you should be able to finish it as well. So it actually says the estimated time to complete this lesson is 16 to 20 minutes, and I think I can beat that. So we'll find it. We'll see. So first, you open your file, obviously. 9 rod. Okay. So it opened up like this, and to be totally honest, I don't know why it's a blue background. If you can tell us why, we will tell you thanks. But really, it doesn't really matter. Now, it says to make sure you're on roles advanced with full menus, so you want to scroll down here. So this list here on the left, where we go to the part navigator and everything, at the bottom of the list, there are 2 people, a little button. It's called roles. So you're going to want to do roles with advanced menus, and you'll watch the buttons will change up here to be all the buttons. So that's what we're going to want to be on. And as we do this optimization, or as we do this analysis, we're going to want to make sure we are in Start, Advanced Simulation. Make sure you do that, because if you don't do that, you won't be able to do anything. So Advanced Simulation is what we're going to be in, and you'll notice now some of the buttons have changed. It tells us to reset the dialog box preferences by going to Preferences, User Interface, and Reset Dialog Box Settings. Okay, so now we have our part here. We're going to want to add a material to the part. So this button here is the material properties, and it says steel. And so let me see if I can. So we want to be steel, and we want to select that part. And so we say, okay, and now that part has material properties of steel. Now we go to the Simulation Navigator, and we select rod.part, and we right-click, and we say New FEM and Simulation. And we just need to make sure that it's an NX-Nastran structural, which it should be. So you go ahead and hit OK. And then it'll bring up this thing, and the same thing, or wait, new box, here we are. It'll bring up this one. Just make sure, once again, it's NX-Nastran and structural, and you'll hit OK. And let's see, yeah. So, all right, so now you'll notice that it's built a lot of different things in here in the Simulation Navigator. Now we have many different things. So, on the simulation file view, which is this part, if you bring that up, you'll see it's created some new parts, including one called rod FEM1_I. So, or actually at first it wants us to save this one. So we right click and say save, and there it saves the part. Now, we're going to be modeling in this part now. What it's done is it took our original rod part and it made a new one, a copy of that called the idealized part. And we're going to change some of the geometry in the idealized part before we mesh this solid so it won't change any of the original geometry. So that's what the idealized part is. And so we're going to make that the displayed part. So we can right click and say make displayed part, or you can double click. Now this is something I noticed the NX 7.5 has been doing, and I included this on the next page of the tutorial. It's going to bring up this warning, and it talks about before you modify geometry in this part, being the idealized part, you must first promote or wavelength the geometry. So basically, we need to make sure the geometry in this part is linked with the original rod part. And so the way we do that, it tells you how to do that here, and I included a picture. If you just go to Insert, Associative Copy, Promote, and then you select this body, and hit OK. Now everything's linked. So just make sure you do that, because if you don't, then you won't be able to do the next thing. All right, so now we want to idealize the geometry here. And so we use this button here, which is Idealize Geometry, and we select which body we want to select. And then we say we want to idealize holes. So basically it's saying we're going to remove some features automatically, any holes that have a diameter of less than 10. So as you can see here, these holes there fit that criteria. And so it's going to be easier for the mesher just to remove those and just fill them in. So that's what the tutorial asks us to do. We hit OK, and now you can see the idealized part no longer has those holes. All right, now it wants us to save this. So right click and save. That'll take a little bit. All right, now once it's finished saving, the next thing we're going to do is we're going to display the FEM file. So this is the part file that holds the geometry, and this is the FEM file that will hold the mesh. So if we double click on this or right click and say make displayed part, then it will make this the displayed part. Now, if you'll notice, this toolbar has become active, which is the meshing toolbar. So we are going to make a 3D tetra mesh, and this body here, and make sure it's a C tetra 10, and the element size it wants us to make is 4. So 4 millimeters, and okay. And there we will see it makes a good tet mesh. All right. So, and we can see that tet mesh here now. So now in this, I'm going to move this. So now in the Simulation Navigator, now we will notice we have this mesh, and we can even uncheck it and recheck it. So there we have it made. It wants us to save again. I'm just going to skip that step. So now once again in the Simulation Navigator, if we go to Rod Sim 1, I think this is what we want. Right, so now we're in go back to the simulation part. And right, then in this one, then we can look at the 3D. Here we are, the 3D collectors, and we can just turn those off because it's going to be easier to look at some, because we're going to be using some surfaces and we don't have to look at the mesh, so it's going to be easier to hide those for now. So that'll just hide them. Okay, so we're going to apply a bearing load onto our part here. So the loads, these are loads and these are constraints. And so if you click on the little drop down arrow, you'll see all the different types of loads or all the different types of constraints. So we're going to put a bearing load, and it wants us to select this surface right here. So there's the surface, and it wants us to make one in the negative y axis. and it tells us to have a force of 1,000 newtons.